Okay, so here's our Vivitar Vivicam camera, and we're going to take it apart and show you how it works. We've got the batteries here, and there's the on switch, and now that we have the camera on, we're going to take a few photos, and you can see the LCD display is showing what's going on there, and letting us see the pictures. Now the LCD is backlit with an LED, which is, LCD stands for liquid crystal display, and LED stands for light emitting diode. So let's go ahead and get cracking. We'll take it apart. We'll take all the screws out that are holding the two halves of the camera together. So we'll remove the top part, and that's likely made out of ABS. And there's a electroplated bezel that surrounds the lens of the camera. It's screwed in place. And that's also probably ABS, plated ABS. Now let's go in and take a look at what the camera's latch looks like and what it's made out of. We've got some, looks like chrome-plated stamped steel connected to a spring, and that feeds the electricity from the underside of the backside of the batteries to the board. And so that's where the positive connection on the board is, and the negative connection is up at the top. So we're going to remove the pin, and we can take the latch out now. Now you can slide the latch back and forth. You can see how it moves. Again, this is plated steel. You can see there's four little connections on there. We'll talk about those in a second, but let's remove this back piece. This is just a simple insert, and I think it's probably heat staked in place. And what that means is really low cost way to attach things. This metal piece is as well. You can see those 4 points there. They're heat staked in, and it is magnetic, so it's a plated steel. And so now we're going to remove the screws that are connecting the plastic bezel that surrounds the camera and connects the two sides. And so you can see it's just an injection molded piece, and I believe that material is ABS, but again, it didn't have a plastic designation on it, so it's not 100%. It could be a polypropylene or maybe polystyrene. So there's the on button and the off button, or I should say the on button and the shutter button, and they push down and trigger the membrane switches, which are mounted on our printed circuit board, or a piece of the printed circuit board that's connected. So now let's take out the screws that are holding the board in place. And we tried to remove the screws for our tripod mount, but one of them is stripped, so we're just going to leave it in place. And I think we'll just pop the back out there, and we'll take a look at the two switch covers. These switches are injection molded, and then they are painted and then heat staked in place. And so you can see the silver colors from the paint, and the heat stake process is basically the plastic, just a little tab on the end of the plastic is melted against the outer part of the housing. And again, it's just a really low cost way to hold the switches in place and keep them above their membrane switches. So you can see which ones go with which. That's the on-off switch, and this is the selector button. These selector buttons allow you to scroll through pictures, and then we have a menu and a play button. So this is our step-by-step of what happens when you take a photo. So the first thing that happens is the lens right here collects some light. So let's take a look at how that happens. So the light's going to come down from the sun, hit Billy, reflect off of him, go in through the lens, get focused on our image sensor, and when it does that, it's going to pass through these two filters. And at this point, photons are what's conveying the information. So it's just the reflected light that's conveying the information to our image sensor. So it's going through the lens and our filters. And so we have an infrared filter here. And the infrared filter is basically it keeps the infrared out, and that can affect the image. We have a Bayer color filter. The Bayer color filter is right on top of the image sensor. And it basically breaks the sensor up into what looks like a checkerboard of red, green, and blue. And there's twice as many green as there is red and blue, because our eyes are more sensitive to some colors than to others. And so the Bayer filter allows us to get color information from our image sensor. So there's two types of image sensors. There's the CCD, or charge coupled device, and a CMOS, or complementary metal oxide semiconductor. Now the CCD tends to have less noise than the CMOS, and it tends to be a little bit more expensive, and the components for doing the analog processing are not mounted on the board. They're usually not on the board. They're off of the board. Now the CMOS has the components, some of the transistors for doing the analog processing on the board, and they are so the CMOS tends to be a lot less expensive. It also tends to have take a lot less power, and it tends to have more noise. So the image quality tends to be less. But again, there are exceptions. If you get a really expensive CMOS chip or really inexpensive CCD, this information may not apply. These are just sort of general guidelines. Once the light hits the image sensor and it is converted into analog electrical signals, those electrical signals are sent to a digital to analog converter, and then the digital signals, and you can see those represented by the ones and zeros, are sent to the digital image processor. So the digital image processor on this particular camera is underneath the screen. It's represented, well, it's underneath the black blob too. The black blob is actually epoxy, and it's put on the board to, it's kind of a low-cost way to protect the processor. And so anyway, the processor is involved in demosaicing, which means that it takes the information from that was created by the color filter and the individual pixels, and it averages those to create a smoother image, and it uses a software algorithm to do that. You can see there's a little hair that's represented there in the super zoomed in view of Billy. Okay, and it can also be used for JPEG conversion and other things. So the memory buffer on our camera is on the other side here. You can see it, it's right there, it's the big chip. And the memory buffer takes the images and stores them before they're sent to the memory card controller, or the octal latch here, and that basically acts as like the traffic control for the data going to the flash memory. And so the flash memory is this chip right here, and the flash memory is where all the data is stored on this particular camera. Now most cameras have detachable flash memory. This one, it's built in, and that's probably because it was cheaper than buying a connector. So the LCD display, you can see, is right there, and that's what displays the image. And then there's our USB connector, and of course you can hook a wire and connect that to the computer and then print out the image as well. That's another way of getting your final image. Take a look at some other components. This is the speaker. It's a piezo speaker, and it produces a high frequency sound when you push the buttons, and that just gives you some auditory feedback to let you know that the button has been successfully depressed. And the board itself is made out of a cloth laminate material. And so if you look at the other components on the board, let's see, there's an LED here and another one here. And those LEDs indicate both when the camera is on and also when a photo has been taken. So let's take a look at, on this side of the board, there's a little silver device, and that's a quartz timer. And the timer helps to synchronize all the functions on the board. It's used by the microprocessor to do that. You can see the resistors and capacitors here. The resistors are usually denoted by the R and the capacitors by the C, and they can be used together to both filter noise, have an influence on some of the timing functions. They can also be used to protect various circuits on the board and various components. So these components here are power components, and they take the power from the battery and make it more usable for the camera. And you can see the traces here. The whole top of the board is covered in copper, and then the copper is etched away in the places that you don't need wire connections. So the wire connections are made with copper that's left, and you can have connections between all the different components there on the board. So we're going to open up our screen and see what's on the inside. So on the inside of the screen, there is a LED and a die, or a resistor, and the resistor protects the LED. And you've got a clear piece of plastic and then a white reflector in the back, and then there's a white diffuser. It's a thin piece of plastic right here, and these pieces, and then there's also a reflective part to the screen. And these pieces are all designed to sort of bounce the light around and help it to diffuse evenly, since there's only one point of light created by that LED. You want to make sure that the image is evenly lit on the back. And the LCD display is in the top, and it's it's sandwiched between two pieces of glass, and those pieces of glass have the liquid crystals inside. You can sort of see that by the smoky color there. You can see through it just a little bit. And they light up, or I should say they turn different colors and are lighted by the LED behind them to display the image when you take a picture or when you go through your images. Thanks to everybody who provided constructive feedback on the previous video. We're always looking for ways to improve.